What if the ocean, our planet's life support system, was slowly turning into a corrosive soup? That's not science fiction, it's ocean acidification. When carbon dioxide from the atmosphere dissolves into seawater, it forms carbonic acid, lowering the ocean's pH. Since the Industrial Revolution, ocean acidity has increased by about 30%. This chemical shift is subtle but powerful, altering the very foundation of marine ecosystems, and the consequences are already being felt across the globe. Tiny marine organisms like pteropods and plankton are the first to suffer. Their calcium carbonate shells begin to dissolve in more acidic waters, making survival difficult. These creatures may be small, but they're essential, forming the base of the ocean food web. If they disappear, the ripple effect could collapse entire ecosystems. Ocean acidification isn't just a threat to coral reefs, it's a direct attack on the ocean's ability to sustain life as we know it. Coral reefs, often called the rainforests of the sea, are especially vulnerable. Acidic waters weaken their skeletons, making them more prone to erosion and less able to grow. This not only affects the corals themselves, but also the thousands of species that depend on them for shelter and food. As reefs degrade, coastal communities lose natural storm barriers and vital sources of income from tourism and fishing. The chain reaction is both ecological and economic. Even fish are affected. Studies show that acidified waters can impair fish behavior, making them less able to detect predators or navigate. Some species struggle to reproduce or grow properly. This isn't just a problem for marine biologists, it's a concern for global food security. Billions of people rely on fish as a primary protein source. If fish populations decline due to acidification, the consequences will ripple far beyond the ocean's edge. So, what can be done? Reducing CO2 emissions is the most direct way to slow ocean acidification. Supporting marine protected areas and sustainable fishing practices also helps ecosystems build resilience. Scientists are exploring innovative solutions like alkalinity enhancement, but prevention remains key. The ocean has absorbed a third of our carbon emissions. It's time we return the favor. Protecting ocean chemistry means protecting life, both underwater and on land. The clock is ticking, but action is still possible.